School of Management Studies IGNOU presents an audiobook on the course Mmpc 008 Information Systems for Managers for MBA program. Block 3 System Analysis and Computer Languages. Unit 10 System Analysis and Design. Part 2.
Implementation. Implementation is the process of putting a system into operation in an organization. During implementation, system specification is turned into working system that is tested and put into use. Implementation includes coding, programming, using computer languages, testing of the developed software system, and installation of the system. In fact, large organizations may adopt this phase into two: development of the software by coding, programming, and testing of the developed system in one phase, and in another phase, system testing, training, and installation of the developed system. The implementation phase being highly technical, with most of the activities done by the IT professionals. The three steps, coding, testing, and installation, have been put under installation phase for business management point of view. The installation phase begins with implementation planning for developing the software by computer programmers using computer language, the process of creating plans for training, conversion from old system to newly developed system, and testing of the system by the technical team and users. During coding, programmers write programs that make up the system. Some systems development projects assign programming tasks to specialists whose work consists exclusively of coding programs. Other projects prefer programmers or analysts who both design and code software programs. Since large systems entail many programs with thousands, even hundreds of thousands of lines of codes, programming teams are frequently used. The training plan explains how and when the user will be trained. The conversion plan explains how and when the organization will convert to new business processes. The acceptance testing plan describes the process and criteria for verifying that the information system works properly and supporting the improved work system. During the system testing, programmers and analysts test the individual programs and the entire system in order to find and correct errors. This is a very crucial and important phase of SDLC because this is the phase which gets the system developed as per users' requirements, well defined earlier in the analysis phase in terms of SRS. Exhaustive and thorough testing must be conducted to ascertain whether the system produces the right results. Testing answers the question, will the system produce the desired results under known conditions? Testing is also time-consuming. Test data must be carefully prepared, results reviewed, and corrections made in the system. In some instances, parts of the system may have to be redesigned. Yet, the risks of glossing over this step are enormous. Testing information system can be broken down into three types of activities. Unit testing or program testing. It consists of testing each program separately in the system. Testing should be viewed as a means of locating errors in programs, focusing on finding all the ways to make a program fail. Once pinpointed, problems can be corrected. System testing. It consists of testing the functioning of the information system as a whole. It tries to determine if discrete modules will function together as planned and whether discrepancies exist between the ways the system actually works and the way it was conceived. Among the areas examined are performance times, capacity for the storage, and handling peak loads, recovery and restart capabilities, and manual procedures. Acceptance testing. It provides the final certification that the system is ready to be used in a producing setting. Systems tests are evaluated by users and reviewed by management. When all parties are satisfied that the new system meets their standards, the system is formally accepted for installation. It is essential that all aspects of testing be carefully thought out and that they be as comprehensive as possible. To ensure this, the development team works with users to devise a systematic test plan. The test plan includes all of the preparations for the series of tests previously described. Users play a critical role in the testing process. They understand the full range of data and processing conditions that might occur within their system. Moreover, programs tend to be aware only of the conditions treated in their programs. The test data they devise are usually too limited. Therefore, input from other team members and users will help ensure that the range of conditions included in the test data is complete. Users can identify frequent and less common transactions, unusual conditions to anticipate, and most of the common type of errors that might occur when the system is in use. User input is also decisive in verifying the manual procedures for the system. During installation, conversion takes place. Conversion is the process of changing from the old system to the new system. It answers the question, will the new system work under real conditions? As a result of conversion process, the new system becomes a part of the daily activities of the organization. Application is installed or loaded on existing or new system hardware and users are introduced to new system and trained. In fact, the system analysts begin planning for testing and installation as early as the project initiation and planning phase, since testing and installation require extensive analysis in order to develop the right approach. For conversion, 4 main strategies can be employed: the parallel strategy, the direct cutover strategy, the pilot study strategy, and the phased approach strategy. In a parallel strategy, both the old system and its potential replacement are run together for a time until everyone is assured that the new one functions correctly. This is the safest conversion approach because, in the event of errors or processing disruptions, the old system can still be used as a backup. However, this approach is very expensive and additional staff or resources may be required to run the extra system. The direct cutover strategy replaced the old system entirely with the new system on an appointed day. At first glance, this strategy seems less costly than parallel conversion strategy. However, it is a very risky approach that can potentially be more costly than parallel activities if serious problems with the new system are found. There is no other system to fall back on. Dislocations, disruptions, and the cost of corrections may be enormous. The pilot study strategy introduces the new system only to a limited area of the organization, such as a single department or operating unit. When this pilot version is complete and working smoothly, it is installed throughout the rest of the organization, either simultaneously or in stages. The phase approach strategy introduces the new system in stages, either by functions or by organizational units. If, for example, the system is workers who are paid weekly. If, for example, the system is introduced by functions, a new payroll system might begin with hourly workers who are paid weekly, followed 6 months later by adding salaried employees who are paid monthly to the system. If the system is introduced by organizational units, corporate headquarters might be converted first, followed by outlying operating units 4 months later. A formal conversion plan provides a schedule of all the activities required to install the new system. The most time-consuming activity is usually the conversion of data. Data from the old system must be transferred to the new system, either manually or through special conversion software. The converted data then must be carefully verified for accuracy and completeness. Moving from an old system to a new one requires that end users must be trained to use the new system with ongoing user assistance. Detailed documentation including SOPs, showing how the system works from both a technical and end user standpoint is finalized during conversion time for use in training and everyday operations. Documentation is produced throughout the life cycle. With the adoption of computer-aided software engineering tools, more of the documentation is basically a compilation of data and diagrams already stored on a computer. Implementation can continue for as long as the system exists, since ongoing user support is also part of the implementation. Lack of proper training and documentation contributes to system failure. So this portion of the system development process is very important. Operation and maintenance. The operation and maintenance phase starts after the users have accepted the new system. This phase can be divided into two activities: ongoing operation and support, and maintenance of the system. Unlike the other steps in the life cycle, these steps continue throughout the system's useful life. The end of a system's life cycle is its absorption into another system or its termination. Ongoing operation and support is the process of ensuring that the technical system components continue to operate correctly and that the users use it effectively. It works best when a person or group has direct responsibility for keeping the information system operating. This responsibility is often split, with the technical staff from the IT service department taking care of computer operations and members from the users department in the organization ensuring that users understand the system and use it effectively. Day-to-day computer operations typically include scheduled events such as generating summary reports from management and backups of the database. The operations manual specifies when these jobs should be done. When the database becomes almost full or when response times start to increase, the technical configuration of the information system must be changed. This is done by allocating more disk storage space and unloading data that are not current. With storage space being cheaper as compared to yesteryears, organizations maintain systems with large storage even on cloud as part of IaaS facility by third party. There are many IT service providers giving infrastructure as a service. If the organization opts to go for complete IaaS facility by the third party, the total solution may be possible to have as SaaS, software as a service. In this case, user organization gets just a link to operate using internet facility. Rest is maintained by the IT service provider. In such a case, the agreement between both the organization and the IT service provider is signed with mutually agreed terms and conditions. Maintenance is the process of modifying the information system over time. As users gain experience with the system, they discover its shortcomings and usually suggest improvements. The shortcomings may involve problems unrelated to the information system or may involve ways that the information system might do more to support the work system, regardless of the original intentions. Some shortcomings are bugs. Important shortcomings must be corrected if users are to continue using an information system enthusiastically. Software programmers make the changes that users ask for and modify the system to reflect and support changing business conditions. These changes are necessary to keep the system running and useful. Maintenance is not a separate phase but a repetition of the other SDLC phases required to study and implement the needed changes. Thus, maintenance is an overlay to the life cycle rather than a separate phase. The amount of time and effort devoted to maintenance depends a great deal on the performance on the previous phase of life cycle. There comes a time when an information system is no longer performing as described. When maintenance cost becomes prohibitive, problems are an indication that it is the time to begin designing the system's replacement, therefore, completing the loop and starting the life cycle all over again. Often, the distinction between the major maintenance and new development is not clear, which is another reason why maintenance often resembles the life cycle itself. Maintenance is of three types. Corrective maintenance. In this type, the errors that creep into the system are removed, hence the name corrective maintenance. Adaptive maintenance. It is done to adapt with the changing external factors. For example, if the government rules change regarding the dearness allowance from X% to Y%, then the changes have to be made in the information system to adapt with the changing scenario. Perfective maintenance. This is due to satisfy the user's requirements to make the system more and more perfect. The steps in each of the phases of the SDLC have now been introduced. The SDLC is a highly linked set of phases where output of one phase serves as an input to the subsequent phase. Throughout the system's development lifecycle, the systems development project needs to be carefully planned and managed. Therefore, the larger the project, the greater is the need for project management. In other words, building information system is not just technical work done by technical staff. It also shows that each phase has specific deliverables that help maintaining the project progress to date and help keep the project under control. Summary. There is a fundamental dilemma faced by anyone developing a computer application. Most problems are so large, they have to be split into smaller pieces. The difficulty lies in combining the pieces back into a complete solution. Often each piece is assigned to a different team, and sometimes it takes months to complete each section. Without a solid plan and control, the entire system might collapse. Thousands of system development projects have failed or been cancelled because of these complications, partly because of the problems that have been encountered in the past, and partly because of technological improvements. Several techniques are available to develop computer systems. The most formal approach is known as the systems development life cycle. Any major company that uses SDLC also has to have documents explaining all the steps in various phases, including SOPs. Mostly, they are soft copies stored for reference as and when required. These documents also contain rules that MIS designers have to follow. Although these details vary from firm to firm, all the methods have a common foundation. The goal is to build a system by analyzing the business processes and breaking the problem into smaller, more manageable pieces.
We were listening to the audiobook by the School of Management Studies IGNOU for MBA program, course code Mmpc 008. Information Systems for Managers. Course Coordinator, Professor Anurag Saxena, School of Management Studies, IGNOU. Voiceover by Renuka. Edited by Ruchi Sharma. Program assisted by Jagbandhu Jana. Program produced by Dr. Manoj Kumar Singh. This program was brought to you by Electronic Media Production Center of Indira Gandhi National Open University.